Start the broadcast.
The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and welcome to the webinar. This webinar today is brought to you through funding provided by the U.S. Environmental Protection Agency. I'm Melissa McCracken with the Kentucky Pollution Prevention Center and will be serving as a facilitator for today's session. Information on the webinar will cover EPA's 6H surface coating regulation and the spray efficiency techniques required. And I believe that we're going to be moving forward with the slides.
Yep.
So the training is brought together through a collaborative effort. As you can see, all the names and logos up there. More specifically, EPA Regions 3, 4, 5, and 10 help to support this training and partnership through 3 different organizations. There is the Illinois Sustainable Technology Center, which was formerly, you all may be familiar with, the Great Lakes Pollution Prevention Roundtable, GLPR. The Pacific Northwest Pollution Prevention Resource Center, PPRC, and the Kentucky Pollution Prevention Center, which is formerly known as the Environmental Sustainability Resource Center as well. And so supporting today's webinar, we have Laura Barnes, who's with the ISTC, and Ken Grimm and Ed Gonzalez, who are with PPRC, and then myself. So for today's agenda, we do have a lot of technical information. We're going to dive straight into that with the spray paint efficiency. We'll close up with some resources that are available to you to help you along the way. Then we'll have questions, and then we'll adjourn. So if you do have questions, please be sure to put them through the question window of your control panel. As you have a question that comes up along the way, go ahead and fill that in so you don't forget. This webinar is being recorded and it will be published. Following this webinar, we will send everyone an email that will include a follow-up survey and also an attachment of the presentation. And when the recording is posted, you will also receive that information. So at this point, I'd like to introduce Ken Grimm, who is the technical specialist for today's training.
Good morning
Ken,
/ afternoon. If you hear, small pauses, it's me sipping my coffee. It's still morning in Seattle, so you'll have to give me that one. We are going to cover quite a bit of information. Generally, when I do this training live, depending on how we do it. If I'm at a facility, I can be there all day. If we're doing a workshop, it's usually about 2.5 hours. So I'm going to whip through a lot of material. That being the case, it's probably going to take the full hour. But for people that are submitting questions and have questions, I will stay on as long as possible after that hour is up to field and answer those questions. So, here's our goal today: get familiar with the 6H NESHAP, and in particular the best practices for efficient manual spray. Look at how they improve quality. Ordinarily, we would be applying some of the training techniques. That's going to be the missing element in today's training. So for folks that are on and are hoping to receive a 6H certificate, what will happen is you'll need to stay on for the entire hour of the webinar. You don't need to stay for the Q&A if you have, production issues involved, but you'll need to stay for the entire webinar, and then I will be, at the end of this, send me an email, and I will send you this form for demonstrating the techniques involved in the spray efficiency. There's a point there for painter and date and observed by. It can be observed by just about anyone. It's better if they kind of know what they're looking for, but you can explain that, and as long as you show that you're maintaining the proper distance and you've got consistent gun speed and good overlap, banding techniques, and keeping your lead and lag to a minimum. Sign that. They can sign it, send it back to me. I will send you out a certificate. You can certainly scan this and email it, and then you won't need it back, or you won't need a copy. But along with the certificate, I will send out an agenda, because unless you all have photographic memories, we're going to cover so much that if somebody asks you what it covered, it's going to be a lot easier to pull the agenda out and say this than it is to try and regurgitate what's going on today. So the important point of this slide is that the NESHAP covers these 5 metals: chromium, lead, nickel, manganese, and cadmium. If you shoot one coating once a year that contains these metals, you are subject to 6H. Now, this is sometimes called the auto body rule. That's a bit of a misnomer because it really is surface coating. But if you, the difference is that if you're a industrial or aerospace facility, you are not required to meet the NESHAP or have the trainings unless you're meeting that one coating once a year standard for these 5 metals. If you are in the collision repair industry, you are automatically in unless you can certify yourself as not using any of those materials and apply to your regional EPA office and or state for an exemption. So it also covers paint stripping operations using methylene chloride. Most folks have moved away from that, and I am hoping you all are as well. There's some additional regulation involving methylene chloride if you are using it. So if that's the case, please contact me afterward and we can talk some more about that. But I don't want to belabor the point on that, except a little bit. I've got some resources for folks. So this is what they're looking at for this standard in paint. 0.1% by mass or more for hexavalent chromium, lead, nickel, and cadmium, 1% more by mass or more for trivalent chromium or manganese. So it requires all painters to complete training in the techniques to minimize overspray. There are some gun cleaning requirements, some routine spray booth and filter maintenance requirements. It requires high efficiency spray guns and documentation of compliance, and then 5-year refresher training. The high efficiency spray guns are listed in the regulation as airless, air-assisted airless, electrostatic, and HVLP. However, there's also a note in the rule that says and or any gun that achieves equivalent transfer efficiency. That was put in there so that as manufacturers create new spray guns, which they have, as long as they meet that efficiency standard, they don't have to go about literally getting an act of Congress to change that. So they do have an area on the EPA website where they have they list I think there's 6 or 7 guns there now that they list, and there are letters that the EPA has issued to the manufacturer noting that those guns meet the spray efficiency requirement as well. So this is just a kind of a fun thing I threw in. It's more fun live because people guess, and the fact of the matter is you're looking at that I cheated and didn't put the correct answer on. This was according to an industry association and a couple other places that got together. The correct answer to this question is 70%. 70% of U.S. manufactured items are fully or in some part painted or receive some kind of coating, which only serves to say that there is a huge amount of surface coating going on. So why address surface coating other than a huge amount of it going on? Well, one of the things they did was they looked at 23 different sectors when 6H was coming out. It was with a group of 23 other sectors that they looked at what the EPA calls toxic weighted emissions. And toxic weighted emissions are those emissions that we're sure cause cancer. There's no such thing as 100%, but these are items that there's a high probability that they're carcinogenic. And so I took some of these as representative samples, agricultural, chemical, and pesticide manufacturers, Ortho, Dow, et cetera, et cetera. In the manufacture of their products, they emit about 312 tons of known or suspected cancer-causing chemicals into the air every year. Pharmaceutical production, which uses a surprisingly large number of solvents, 523 tons. Paint allied products, this is your PPG, your Sikkens, your Rada, your Sherwin-Williams, all your paint manufacturing folks, almost 2,400 tons of known cancer-causing chemicals into the air every year. Industrial boilers, which is mostly the byproducts of combustion, about 2,600. And flexible polyurethane foam operations, almost 5,300. And by the way, flexible polyurethane foam operations is number 2. This particular figure is for collision repair. It doesn't count the impact of the industrial sector, which is also huge. It doesn't count the impact of the aerospace sector, which is also huge. But just the collision repair sector, over 45,000 tons of known cancer-causing chemicals emitted into the air every year during their routine business operations. So when folks are, small businesses want to know why they're being addressed with a regulation that's this detailed, that's a quick look at why. The aggregated effect is huge. In fact, collision repair and paint operations in general are more than double all of the other categories combined. So spray gun cleaning, what it really says there is that the important point in this is that no more atomization of solvent. For those of you who have painted long ago, and never mind how long ago I painted, for those of you that painted long ago, the method was to either fill the cup or put the wand in a bucket of solvent and then go turn the booth on and spray into the filters until solvent came out and the gun was clear. That's out now. You can reduce pressure and take the tips off so that it's a controlled stream. You can hand clean or disassemble them. You can use gun cleaners. I personally am a fan of gun cleaners because they allow painters to put the guns in and turn them on and go away and do other things while the guns are being cleaned. But there are folks out there that I've heard of that have told people that they have to have a gun cleaner. That is not true. That is one of the acceptable methods, but you're not required to have a gun cleaner to clean spray guns. You just can't atomize solvent anymore. All spray coatings must be done in a booth or a prep station. If it's a complete vehicle, or I believe for industrial, if the item you're painting is more than 14 feet long, it has to be in a booth. And the booth has to have 4 complete sides and sidewalls or curtains and a roof, and it has to have negative air pressure. There can't be any escape of emissions from the booth. If there's smaller sub-assemblies or parts that can be done in a 3-sided booth. But one of the points to note is that one of the things that was in consideration in this rule and is in consideration in others is that the EPA is very aware of the problem of competitive imbalance. And so one of the things they did with this, by making it all work done in a booth, et cetera, is level the playing field. So somebody in one area doesn't have an advantage by, we had one competitor in a facility I managed years ago that we had to comply with the Puget Sound Clean Air Agency standards, and they just pulled everything out into a concrete pad outdoors and sprayed. Filters are part of this. This came, I think the drop dead date for compliance was January 10th of 2011. And so by now, most places have made the switch to 98% efficient filters. Most vendors provide that because it's easier than having their customers scream at them when they get dinged for not having an efficient enough filter. They do ask that you have on file a filter test report. And most of those, this is a look at what those look like, but most of those are on the manufacturer's websites, and most of the manufacturers that I've seen had them somewhere easy to find on the front page, because they don't want people calling them and using up time all the time just to get a copy of the filter test report. So in your documentation, if you're 6H, if you need to comply with 6H, there should be a copy of this as well. These are some of the extra things you have to do for methylene chloride. Like I say, I'm not going to belabor that, but if you want to contact me for more information after, please feel free to do so. This is a look at, this actually came from the California Department of Public Health and the Environment. And I like this because in particular, they don't list all these ingredients and tell you, go forth and find things that don't have this. They actually have the product name. So it's a lot easier for you to look on a shelf and look at the list and go, yep, that's on the don't list. These are products that contain, as you can see, most of them contain methylene chloride in some format, as well as methanol and toluene, which is another suspected carcinogen. The ones down there on extreme caution, the one thing I will say with that is that they replaced a lot of those initially, a lot of the strippers with from methylene chloride to N-methylpyrrolidone, and we have since found that that would be what we would call a regrettable substitution, since NMP is really not much, if any, better than methylene chloride, and in fact is on the TSCA chemical list along with methylene chloride to do away with. So the ones in yellow, and particularly the ones in green, are what they recommend. And I have these, and am happy to send them to you again if you want to contact me and ask me for them. This particular one is an Excel spreadsheet. This one was put together by Larry Garcia, who's the senior environmental analyst at Seattle City Light. And what Larry's general MO is he'll take these out into the shop, and he'll provide them to the workers in the shop and say, hey, try this and tell me what you think. And if they come back and go, well, yeah, it took the paint off, but I had to wait 6 hours instead of 30 minutes. Okay, not going to be much helpful in a production environment. If they come back and say, I can live with that, that one's okay, then Larry puts it on his list, and those are the green ones you see here. So if you do use strippers, or you do need strippers, these are workable ones that get you away from hazardous chemicals that you don't want certainly breathing in. You don't want it on your skin. You don't want it on your clothes. You don't want to take it home to your family. So most of the spray efficiency techniques that we're going to be looking at came from a program initially developed by the Iowa Waste Reduction Center at the University of Northern Iowa. They got a grant by the Small Business Administration and the EPA, and it was to look at what really affects transfer efficiency the most, and how you can what sort of best practices are available to help keep that going. And the first thing they did was they took things that painters don't have control over, like the air supply system, the airflow, the rate, the lighting, that sort of thing. Nothing you can do about that as a painter, so they threw that out. And other uncontrollable variables, size and geometry apart, coating type of color, the finish requirements, those sorts of things. They're customer determined. You got the job because you said you'd do what they asked, and you can't change now. So they looked at the things that do affect painters, mixture content, the operating temperature of the booth, type of equipment, maintenance practices, gun setup, and in particular techniques, spray distance, spray angles, spray techniques, and the plan of attack before you start shooting an item. So we're going to hear a lot about transfer efficiency. This is our working definition of transfer efficiency: how much paint sprayed is actually applied to the part being painted, how much of what you shoot in the gun gets on the part instead of the floor, your clothes, the walls, and the filter media. And this is how we measure it. And you can quantifiably measure transfer efficiency. But these are the two common methods of doing it: volume or mass of solids deposited over the same sprayed. One of the reasons that we focus on transfer efficiency is obviously the material savings and cost efficiency of that, the health impacts of the materials that are used in particularly solvent-borne coatings. In fact, this is a look at some of the ways both acute and chronic exposure, overexposure rather, affect the human body. And for those of you that are painters, you probably know some older painters or know some guys that shake a little bit because they have central nervous system damage from all the years they painted, and particularly all the years they painted with very poor or no PPE. The first car I painted was in 1974. I was a senior in high school, and we used what everybody else in the shop used, a dust mask. So I'm out of the booth now. I can still go in and do things, but it's not a career opportunity for me because I have occupational asthma, and that's from chronic overexposure. There are lots of other things here that so this is my excuse me, sorry about that. This is my
call from GWA.
Hang on, let me
Call
get to the
from
phone.
GWA.
Sorry about that. So in fact, let me just unplug that while I'm talking. The thing I want to mention here is that over the years, not only has personal protective equipment gotten a lot better, but the number of it and the amount of it, but the use of it has drastically improved. So you could be a painter now. If you retired as a painter in the 60s and 70s, statistically you were dead before you saw your second year of retirement because of the toxicity of the materials you worked with. And now you can have a long career as a painter, and you can have a long, happy retirement as long as you use the the PPE that's available to you to protect you from these types of exposures. So, and then environmental impacts and liability impacts, both from possible actions from the community you live in, and or I have seen places that drastically reduce their VOC and HAP emissions, and their insurance premiums went down as a result of it. So the other thing about transfer efficiency is that I don't know if any of you have ever had your transfer efficiency measured, but even a good painter probably has a transfer efficiency of less than 50%. And I have actually done quantifiable measures on painters for several years, and as has Iowa, and that substantiates that figure. Painters, my experience has been they generally are between 35% up to maybe 45%. I did find one paint instructor at the Darrell A. Dennis Tech Ed Center in Boise, Idaho, that hit 52% before the transfer efficiency techniques. He's the only guy. So, and the other thing is that 10% improvement, 10% off the figures that we looked at previously is like wiping the next highest category off the map. So I have this slide because I'm more of a visual guy. So the darker piece of the pie on the left-hand side, that's how much paint you purchased to put on your part. The brighter turquoise is how much paint you buy so you could throw it away at 40% transfer efficiency. And in fact, as a business, it's even worse than that, because that turquoise piece of the pie, that 60%, not only is that a purchase to throw away, but in many cases, you're purchasing that and then paying somebody to haul it off for you as hazardous waste. Most businesses have buried this kind of information in the cost of overhead. They don't really look at this kind of thing. But when you do take a look at that, it's really astonishing what the costs of poor transfer efficiency for a business are. So I'm going to skip through this because we'll come up again with these at the end of it. But suffice it to say, you can look at transfer efficiency and see two things. First of all, that the better your transfer efficiency, the better the cost savings. And second of all, you reach a point at the right end of the scale where the savings are less and less with the transfer efficiency. So we talked a little bit about transfer efficient spray guns, and the one thing to mention about that is that like an HVLP is listed as 65% transfer efficient. That's 65% transfer efficient in a lab under ideal conditions. Most people that are using HVLPs fall under that less than 50% category, which is why the spray efficiency techniques were added to this regulation, because it was determined that even with a transfer efficient gun, you're not going to get the same results in the real world that you got in the laboratory. So we also look at, in addition to transfer efficiency, because transfer efficiency is an important measure, but it's not the only measure, because you can have 100% transfer efficiency, but if the mil spec on the part was 3 mils rather, and you put on 6, you still wasted 50% of your paint. So between 40% transfer efficiency and 150% of the build, you could be wasting at least 3/4 of the paint you purchase through inefficient technique. So, and I'll skip this. This is just by way of showing the formula for measuring build efficiency. So we're going to look at some videos. These are the things that we'll cover. Spray distance, staying perpendicular to the surface, and having good angles, keeping good overlap, banding and edging, and reducing lead and lag. So mixture content, we talk a bit about that more in industrial and some aerospace facilities, because they still use material that the painter will go out and thin to the point that they like to spray. And I have seen, in fact, I had a painter who thought that, the solution to every problem was thin the material. You weren't getting good gloss, thin the material. You were getting runs, thin the material. And those painters still exist out there. So one of the things about the regulation that it requires is that you have viscosity checks. And the regulation doesn't say how frequently these viscosity checks should happen, only that they should happen. So my recommendation to folks, and I've actually done this at EPA sponsored trainings where they brought me in to do the spray efficiency training portion and some of the 6H stuff. My recommendation, and they have agreed with it, is that you do it quarterly. And so for those of you that have never done that, it's usually on the product data sheet. You'll generally see, it'll tell you that when it's mixed to manufacturer specifications, there's a certain viscosity reading. You'll get 28 in a Zon 2 cup or something like that. The reason I say 4 times a year, winter, spring, summer, fall, one of the things that affects viscosity is temperature. And so that kind of helps you cover all of those bases for the most part. If you're in the collision repair industry, as long as you have those product data sheets, they don't really require you to do the viscosity testing, because for the most part you're mixing up plural component coatings. So you're getting 4 parts A to 2 parts B to 1 part C, or some such. And that being the case, as long as you're mixing up according to manufacturer's specs, the viscosity should be what they say it is, and that's an acceptable record of viscosity readings as well. So guns need to be cleaned and maintained regularly. If you own your gun, you're probably really good about that. If the company owns your gun, that can be questionable. The facility I managed, we had the day shift painters at the end of the night hung up the guns and went home because the night shift painters were going to come in and paint some more. And at the end of the night, the night shift painters hung up the guns because the day shift painters had plenty of time to clean them while the booths were being emptied and reloaded. Consequently, nobody cleaned them until I went in and said, that gun is a sticky mess, clean it. So some companies like, I think it was Genie Industries at the time, and they're Terex now, but they actually have maintenance people, and they go in every night and clean and maintain the guns so that they don't have that issue. But it does have a, maintaining the gun can have a big effect on your spray and which affects your efficiency. So the first thing to set up is fluid setting. So you can be at places where, I've been at places where they crank the fluid setting up. It's a pretty common thing to see out in a production environment, that you crank the fluid setting up so that it throws more paint out so that you can paint faster. The problem with that is that when you crank up the fluid settings, you have to crank up the air pressure settings to get the atomization you want, and all of a sudden you have a gun that's really not spraying efficiently at all. I was at ESCO in Portland, and they make teeth that are like for backhoes and shovels and things like that, and they'd come off a conveyor line, and they went into a booth with kind of 5 Lazy Susan type turntables on a larger turntable that was operated with a foot pedal, and they would spray it and then move to the next one and then flip it over and spray it, and it would come off onto a belt while they reloaded from the other belt. And the guy that was painting that, the painter in there was painting furiously. There was a huge cloud of dust. You could hardly see the filters through the overspray in the back of the booth. And so we went back, and the fluid settings were cranked way high. So we turned the fluid settings down to where the recommended pressure was, and we tuned the air pressure into just what he needed in order to effectively atomize that. Checked the spray pattern a couple of times until it looked good, and then he went back in the booth, and I didn't say anything. We just gave him the gun, and he went back in the booth. And I think he was pretty frustrated for a while because it forced him to slow down. And what's true about painters is that they all think that moving your arm faster is more productive than moving your arm slower. But the fact of the matter is, at least in this instance, was he was not having to make as many passes. He was not having to move his arm so furiously. He was getting better coverage on the slower passes he was getting. And his supervisor was the first one to notice that the parts that were coming off on the conveyor line every 18 inches were now coming off every 12. So it seems counterintuitive to say, turn all this stuff down and you'll get more production. But it can and does happen. So you want to keep the fluid setting as low as possible while still maintaining comfortable gun speed. Fluid delivery too high. These are some of the problems you see. Runs or sags. Solvent popping. If you've ever seen little pinhead bubbles in a coating, there are several causes for that, but one of them is the solvent popping. What happens when you're spraying paint, the manufacturer has designed a certain amount of flash to happen between the gun and the substrate. So as you're changing the distance, you're changing that flash, you're changing the overlap, you're changing all of those conditions. And if you crank the fluid up too high, those solvents that are designed to flash get trapped inside the coating, and as the coating skins over and develops that surface tension, those high flash solvents are trapped, and that's what causes that popping. Fluid delivery too low, you can get dry spray, you'll need more coats. your productivity will go down. And by the way, one of the reasons that spray efficiency techniques are part of this was that there are very few in the collision repair industry. There are they all have schools for auto body, and part of that is they usually spend a week or two on paint. But for industrial painters, the vast majority of industrial painters learn to paint from somebody that learned to paint from somebody that learned to paint from somebody. And their technique is all over the board. So what they've learned is to give their boss the two things their boss wants: do it fast and do it right. Do it more efficiently, and do it so that it saves money. Not been part of the painter's toolbox until now. And as we go through this, the other thing you'll see is that fluid delivery too low looks a lot like air pressure cranked up too high, and vice versa. So the air pressure settings should be set at the lowest setting that allows you to properly atomize the paint. The air pressure is there for really two reasons only. We'll go back to it later. Those are to help atomize the coating, and to help shape the fan pattern. And like an HVLP, really an HVLP should be about 10 psi at the tip. So if you have a fitting with a pressure gauge like this, it's usually set at the base of the gun at about 29 psi, because there will be some pressure drop when you squeeze the trigger. And usually if you set it at about 29, you should get about 10 psi at the tip. They also have gauges like this that you can, on an air cap, that you can put on the tip of your gun and actually measure what your air pressure coming out is. But that should be set, as low as possible.
And I just want to let you know we're a little past the halfway mark.
Okay. I think we're doing okay. Let me know in 15 minutes. So, some of the best practice, I'm going to go ahead and skip this slide then, other than that we will look at, spraying test patterns like this. So one of the things we're going to talk about is using the proper size tip for the item being painted. And this is just a quick look at the difference. It's fairly noticeable between a 1.4 and a 1.3 tip. That's sprayed at 29 psi. That's at the base of the gun, so it's 10 psi at the tip. And you can see those are actually pretty nice spray patterns. If you look at the one on the left-hand side here, that generally is either fluid pressure too high or air pressure too low. The one in the center is a pretty decent spray pattern. The one on the right is usually air too high. So we're using, getting the gun set and shooting a spray pattern, hanging a piece of, paper or cardboard in the booth and just giving it a quick shot using a spray pattern helps you know that you have the gun set where it's going to give you the best spray and most consistent spray, which consistency equals quality when you're in just about any field. The other thing about gun setup is that, shooting that spray is it can tell you things like, do you have a plugged air passage, or is the fluid needle not set right, or is maybe is the nozzle bent, or is your pressure settings wrong? So I do this once a week when I was actually spraying, and I have my guys do it the same, just so that it keeps you aware of what's going on, and it helps address problems before you see coating issues once they get out of the booth and out in the sunlight. The other quick thing I'll mention is that this is a really good chart that shows the difference in air pressure drop between a 5/16 inch hose, which some places use in order to save money, and a 3/8 inch hose. If you look at that, if your line is 50 feet, at 43 psi at the inlet, you're going to lose more than almost half of that, not quite half of that, but you'll lose almost half of that after 50 feet. versus if with a 3/8 inch hose, the drop is going to be less than a quarter. So using the proper hose is also helpful when you're making these adjustments and getting everything set up. So fan setting, one of the things I look at, and you can do some adjustment at the gun, or you can do some adjustment. You can make the adjustment by using a different tip. There are guns out there. The 3M PPS is one, and there are a couple others that or ordinarily you pull the trigger halfway and you get air. You pull it all the way, you get fluid. With some of these guns, you pull the trigger partially, you get air. You pull it a little more, you get that partial fan pattern, and you pull it all the way, you get a full fan pattern. The advantage to that is, say you're in the collision repair industry, is you can run that partial spray pattern on the inside lip of a fender instead of having to do what you see here on the pour pattern, which is spray this wide spray where you're wasting almost 2/3 of it, by default. There's no way to avoid that. You can also try to change the gun orientation, which, we, for the most part, we argue against. It's not etched in stone, but it's certainly a try to avoid. And the best thing is to get a tip and set it so that it really gives you the most efficient spray for what you're shooting. Again, here's the look at the air cap. You can see the nozzles in or the ports in the air cap are simply to provide atomizing air to shape the fan pattern. The ports in the fluid tip are there to help atomize the material. So air pressure too high, you can see it looks a lot like fluid pressure too low, low transfer efficiency, low film build, etc. Air pressure too high, same thing, excessive film build. You're more likely to see orange peel from that, and you're more likely to get runs and sags. So gun distance, there's a lot of information about gun distance. For that being said, I generally follow these guidelines. For an HVLP, average distance should be about 6 inches. I've known people to spray 5. I've seen, 5 to 8, 6 to 9. I've even seen some places that said 10 inches for an HVLP, but I personally think that's too far away. Air-assisted airless, 8 to 10 inches or so is probably ideal. Electrostatic, 8 inches, if you can do it. 8 to 12 is still functional. And for an airless sprayer, 12 to 18 inches. I know there are certain industries where they'll crank it up more than that in order to throw more paint out. But if you measure what's being wasted when you do that, and realize that you're changing a lot of the flash of the coatings and the conditions of cure and all of that, it's better to have the set 12 to 18 inches if possible. Just real quick, if you're too far away, what you're doing in essence is building up particles, and instead of a fluid coating, it's not going to be quite like that because there's still going to be some fluidity to it. But if you looked at it under a microscope, you would see a mix. And if you're too close to the panel, that's when you see that center blowout, and that, among other things, can be a cause of tiger striping that you see sometimes in paint jobs. So keeping the distance consistent. This is a look at that. You'll see the laser paint device on the gun. That was developed by the Iowa Waste Reduction Center. It's currently not in production, but I do have a couple loaners. So if somebody wants to write me and ask to borrow it, I will send it to you. You can keep it for about a month and you can send it back. It mounts easily on the gun. You can set it to the distance that you generally spray at. And when you move the gun in and out, that one laser dot becomes 2. You'll see it as he comes off. He'll go across the panel, and as he comes back off, you'll see it breaks off. But in the meantime, you can see that he's just right on here. This is a really good look at consistent distance. And there you can see where it came off. That's not much difference in distance down there, and it is broken into the 2 dots. I can tell you the first time I ever sprayed with one of those, it really drove me nuts because I was a good painter, and it took me a long time to get that. Well, not a long time, but the first few times I painted, it was really annoying trying to make that thing become 1 dot. But the interesting thing is that muscle memory picks that up pretty quick. And we put those in at a facility in Monroe, Washington, and for most painters within about 20 minutes. And I think the longest person took about 40 minutes before that laser guide was dead on every pass they made on every part that came by the conveyor. Arcing the gun, we see this a lot. It's usually arm or shoulder. He's doing one of the things that you commonly see. So this is kind of a demo. He's doing it with a laser fan pattern, and he's sort of exaggerating it, but you do see that sometimes. One of the primary places I see that was with painters who are new, and they did what he did right there, which was stand rooted. They didn't glide back and forth with their legs and hips to apply the coating. They just stood in one spot, and there's no way to come across your body with that gun and not change your orientation. And when you change your orientation, you're changing the distance, you're changing the angle, you're changing the flash, you're changing the overlap, you're changing all those things. So the one area that that doesn't apply to is if you are blending coatings, whether it's a large piece and you're doing overlap as you work your way down it, or whether it's something previously sprayed like a fender or any other piece that's got that you're doing a patch on. Then the gun would be arced because you need to do that in order to get the overlap and get the proper blend. But other than that, overlap is something to, arcing is something to avoid. Yaw is moving the wrist left or right. This is an example of that. I don't honestly know, other than, again, a blending situation, I don't honestly know where this came from, but it seems like every painter sees the painter they're learning from do that and thinks that's part of being a good painter. Honestly, it isn't like it's a horrible thing, but if what you're trying to do is maintain consistent distance, what that essentially means is you come across with consistent distance and then lose your orientation and get it back, and come across with consistent distance, lose your orientation and get it back. And really, what's the point? Plus, the other thing we'll talk about later when we talk about lead and lag is that I also see people that do that and don't trigger the gun. So they're just basically spraying paint off to the side into the air for no reason at all. This is kind of look at the way the pattern changes with yaw when you're moving the gun back and forth. Pitch is having the wrist turned up or down. I will apologize for this video unabashedly because I've never seen anybody paint like this, and I don't know how many joints you'd have to have in your wrist to do it. But he's demonstrating pitch from both possible angles. So that I would never see. That is pretty common. I see that all the time. And particularly something like that where it's a large part, large flat piece, the roof of a vehicle, sometimes, the hood of a large vehicle, that sort of thing. And, it's hard to reach out like that. Plus, if I go back and, the way he held that gun before at an angle, that's the more ergonomically natural way to hold the gun. To hold the gun way out at a 90-degree angle is kind of uncomfortable. So you don't, without thinking about it and making it habitual, It's just something your body naturally doesn't do. But when you do that, you can see here again how the fan pattern changes. It changes the distance, it changes the orientation, it changes the overlap. Rotation, which is turning the wrist either clockwise or counterclockwise. In this case, he's almost doing it with his arm. But again, you can see part of the problem here is being rooted. He's standing in one spot, and so your natural inclination is to end up with a mild, or even I've even seen cases where you ended up with kind of a moderate rainbow effect because of rotation. And you can just imagine all of the issues with that when you're trying to get a good consistent coating. So lead and lag. Lead is the distance between the point where the gun's triggered, where you squeeze it as you're coming onto the part, and lag is where you let go after you come off. And so one of the things that Iowa particularly worked with when they worked with painters was lead and lag. Conventional lead and lag he's doing here, and we'll see the paper on the wall in a bit. But one of the things we did was lay these papers out so you could compare before and after and see if this paper wasn't here, the technique he's using, I would expect to see in just about any shop I looked at. So that's pretty common lead and lag. So this is improved lead and lag. Now you can see the difference on that is pretty substantial. And when you hang up the sheets and take a look at them, you can see that. And if you measure that exterior overspray, excuse me, that is probably somewhere between 5 and 10% of the coating that you have reduced just by minimizing your lead and lag. I will say this as a former painter. That was, the laser was frustrating. This one was nerve-wracking because no painter wants to start too late or let go too soon. So it took me a bit of practice, but it didn't really, again, take very long before I had that improved lead and lag down, and it was making a big difference in the amount of paint used, particularly over and over again. The last facility I was at, we shot about 125 gallons of material a day, so it was a pretty high production environment. Well, if you can remove 20% of that, you're talking about 25 gallons a day. That is an incredible amount of money over a year of production. The other thing I want to talk about is a lot of people grab the trigger and don't let go because they say it's easier. Or they're afraid their hand will get fatigued. I have these slides up about trigger figure. That's not something that, there's no consensus on whether or not that actually is an issue for painters. It is for welders. If you're a welder, it's likely at some point in your career you had this, and maybe multiple times. But the point of this is that the bottom right-hand slide, your hand curved like that, your hand pulling on the trigger and curved, that's not the ergonomically comfortable position for your hand to be. Hopefully nobody walks around with their fists clenched. You walk around with your fingers straight up and loose. So really that, triggering the gun shouldn't be an issue for any painter out there. It wasn't for myself or my guys, and we probably painted 6.5 to 7 hours of every 8-hour day. So the other thing that they looked at is conventional banding. I don't think they talk about this much anymore, and I'll show you why. So this is pretty much conventional banding. You're going to start half on, half off. That's where you begin your 50% overlap. And as you come off the part the other way, you're going to do the same thing. You're going to come down with the tip of that gun right at the edge to finish your 50% overlap. So you look at the amount of paint, solid spray on there. So I always said, well, let's try full fan banding, keeping as much paint on the part as possible. Which is
5 minutes.
Okay, so which is what he did here. And so as you look at that, you can see there's just barely a little overspray coming off of that. The problem with that is the edge is going to be the most likely place to get damaged, and now it's going to be the place that's light on coating. So that is one area where I tend to rotate the gun and make a fast pass down the first part of it. That's one technique you can use. You have to move twice as fast because you're putting twice as much paint in an area, but it is effective at helping saving a bit of the coating. So we're gonna skip that and go into the assumptions for their figures. You can see they were assuming 12 hoods and 12 fenders a week for 50 weeks, 2 weeks of vacation. They're using the cost of coatings as $150 a gallon for automotive paint. Cheap white is like double that now. And so they figured, if you're at 40% transfer efficiency using those figures, you're going to use about 212 gallons of paint a year. If we can improve 20%, which is what they traditionally got, they quantifiably demonstrated a 22% improvement among all their painters. You can get from 40 to 50% transfer efficiency. That's going to be a savings of over $6,000, adjusted for inflation, times however many painters are doing that work. And you have savings available also in build efficiency. Now, if you were shooting, say, 4.5 mils at a 3 build target, the one thing I'll tell you is that I would never come up and say you want to get 3 mils. And I would never do that for 2 reasons. One, all painters are going to put more paint on than less. You never want to be under that target film build. And the second thing is that I have actually taken my mil gauge to new car lots and gone down the hoods and fenders, and you'll get readings like 3.48, 3.61, 3.39, 3.52, 3.74. And the point of that is that those vehicles are all coming off an assembly line sprayed by a robot. And if a robot can't get exactly 3 mils, it's ridiculous to ask a person to. So if you're at 4 and a 5, I would try and move you down to like 3.9. And you're still going to look at, a couple of $1,000s of savings plus inflation adjustment plus the transfer efficiency stuff. So here's another look, and I'm not going to go over this, but just another slide to look at, if the coating cost is $40 a gallon, what you get when you look at different build and transfer efficiencies in terms of costs of coating. So the one place that for sure did a case study was Woodfold Manufacturing in Oregon. I did the training down there, and they calculated that in the first year they saved about $3,000 in labor and material savings for filter changes they weren't doing anymore because they weren't filling them up so fast. And they reduced their paint use by $34,000 while their productivity went up 10%. So they're saving, $37 plus $1,000 a year just from implementing the spray efficiency techniques. So the left is a Zahn cup. Those are kind of expensive. They use surgical steel. Most vendors have a plastic one, so if you need to do viscosity checks, they might even just give it to you, but they certainly would have a cheaper one available than these. These are nice and they should last forever, but it's not required that you buy one that expensive. So the record keeping for 6H, if you're subject to it, you need to send a notification to the regional office of the EPA. You need to keep the painter training certifications on file, have the booth efficiency documentation. And, if there's M-methylene chloride, you need to keep that documentation. And you need to keep the viscosity checks. And if needed, spray gun transfer efficiency and the methylene chloride minimization plan. And if there's issues, deviation and corrective action documentation as well. So I think that is it for me. I'm going to hand this back to Lissa. How are we doing, Lissa?
Okay, we're right on time. We
Okay.
actually had a minute to go.
Good. Thank you for your attention, everybody. I'm sorry I talked so fast, but we did it.
You did do it, and I'll let you take a look and see if there's any questions. I do want to just briefly mention there is a handout that is attached that you should be able to see in your the window pane. There, it should be pointing to a handout and say one there. And what we did was put together some resources that you can take away with. For Illinois and for Kentucky, ISTC and KPPC, we provide technical assistance to our respective states. PPRC, they do provide assistance primarily to Region 10, but as far as some of their programs, such as their spray efficiency program, they extend out beyond that. So you're definitely encouraged, no matter what state you're from, to contact them as a resource. And then we've also provided a link to where EPA has on their website different technical assistance providers respective to whatever state you're in. And if you have any trouble finding assistance, you can certainly contact any one of us from this webinar, and we'll help to put you in touch with that. And we do have some general P2 information, and it's a LibGuide that is sponsored through Illinois. And within the LibGuide, there's actually a specific painting and coating LibGuide, so there's lots more resources there. We just pulled out some to help to get you started, or hopefully make you aware of some things you weren't quite aware of, and hopefully this will help get you on your way. So with that, I think we can advance one more. It'll have our contact information and also available for questions. Ken, you have the questions there?
I've got the box up here. And it looks like the first one, the person said he has 2 attendees, was only able to register 1. And they did give me the name of the second one, and that's fine. I'm assuming that they are making that known to me because they would like to get a certificate for both painters, and that's fine. For anybody that was the case, or you registered and you've got, your 4 painters or 8 painters or 15 painters in the room with you, as long as they have seen the presentation and they can all go out and check each other on the demonstrating the spray efficiency techniques, and you send me that form, I will certify all of them. So the second question is, someone is not able to hear the presentation. I am sorry, we did not see that earlier, Lisa. Hopefully that has improved. If not, again, I can only offer my apologies. Next up, someone says, recently Kansas has required, she's left. Nancy left. Some research indicates Iowa is similar to our state, but Ohio has a 6H Q&A document that indicates the petition for exemption is only needed for collision repair. So for mobile sources, the issue with that is that if you are only using a 3-ounce cup, which would be like an airbrush or a teeny tiny gun, if that's what you're doing when you're doing mobile work, you are not required to follow 6H. You're not required to. I mean, the force people to use a booth in that circumstance would just be put all the mobile operations out of business. So the issue for that is, again, the 3-ounce cup. If you have a full HVLP, or if you have a full-size cup on your vehicle and somebody comes around, they will ding you and they will make you comply with 6H. But as long as you don't have anything larger than a 3-ounce cup available for use in service when you're out in the field, you don't have to comply. The other thing with that is that if you're doing field work with commercially available spray cans, then that's acceptable. You don't have to have you don't have to worry about compliance with spray cans. But if you are using custom spray cans, if you're having your own blends or refilling them or something like that, then you are required to follow the dictates of 6H as I last heard it. So let's see, how do you estimate the rated capacity of a spray gun to estimate maximum VOC emissions? Yeah, so and then they ask again what a 98% transfer efficiency referred to. It is particulate. There aren't any filters that transfer out VOCs that I am aware of. That you'd have to have some sort of activated charcoal filtration or a thermal destruct or something like that. In terms of VOCs. Estimating a spray gun's maximum VOCs, that the only way to that I know of to do that is to calculate VOCs is just calculate, because we always did a mass balance because it was easy, and the fact is that if you're using 3 gallons of paint, at some point in time 3 gallons of paint are going to flash off and emit VOCs, so you would just use the total of that versus what a gun's maximum VOC emissions are. A gun's maximum VOC emissions are whatever you spray. So is the HVLP the best gun to minimize air emission VOC? I'm going to say that if you're trying to emit VOC, reduce VOC emissions, then whatever gives you the best transfer efficiency is that gun. Personally, I am a big fan of electrostatic guns, but they do have their limitations, and both in types of coatings. For example, you can't really shoot metallic with a HVLP because the metal flake is supposed to lay flat, and when you ionize the paint, it polarizes the metallic particles, and they tend to stand on end instead of doing so. But if you're shooting a lot of flat surfaces, a lot of tanks, pipe, things like that, an electrostatic gun can provide some severe savings. We were shooting large industrial refuse boxes, drop boxes, 40-yard containers, and we went from shooting about 9 gallons of primer and 7.5 to 8 gallons of paint on those to about 5.5 gallons of primer and 5 gallons of paint with an HVLP. With an electrostatic. Are you going to share a PDF of the presentation? Yes. We are going to share a PDF of the presentation, and the recording, I would say I will do everything I can to get it out the first part of next week. I'm actually out the middle of next week doing some field trainings, so I will do what I can to get that up Monday or Tuesday. So I don't. So the last person asked if I have a Spanish version of this document. The short answer is maybe. I don't have one for this presentation, but we have done some bilingual training with our executive director, Ed Gonzalez, joining me in the field, and he has translated the slides so that what you saw here, that's the same slides also include Spanish translation. And so if you email me, I'm happy to send you that. The one thing I will say is that the presentation will probably be a PDF, so the videos won't work, but it'll make it easier to transfer or easier to pass around by email that way. So that's all I see here. If anybody else has any questions, I'm happy to field them at this point. If not, we can call it a day.
Okay, so if you don't see any more coming in, thank you very much for your time. It was a lot of information, so we tried to just get this moving as quick as we can, and so many of you all actually stayed on. and hung in there, so that's great. And certificates will be coming out, and you'll hear more from us. Thanks again, and contact anyone here if you should have any follow-up questions.
Yeah, thank you, everybody.
Everyone have a good day.